Ladies and gentlemen, I am John Kumar Shah, Professor, Bangladesh Agriculture University, welcoming you to my presentation. My presentation title is CFD Simulation for Understanding the Effects of Wind Direction and Surrounding on Airflow and Air Exchange Rate of a Natural Ventilated Dairy Building. As you know, the ventilation in building is necessary for creating comfortable environment with acceptable indoor air quality. Stall air badly affects the milk production and milk quality. However, animal activity changes in response to heat stress and insufficient fresh air. Because of this great variability of the climate parameter involved and the surroundings, a numerical model of a typical natural ventilated barn for predicting air exchange rate and airflow characteristics in space has not been found. Therefore, the aim of this study was to develop a CFD-based numerical simulation model for a natural ventilated barn located in Northeast Germany for understanding airflow characteristics and estimate air exchange rate of the natural ventilated dairy barn for different airflow directions and surrounding structure. For the study, we have considered a typical natural ventilated building and its surrounding located in Northeast Germany. If we look at this figure 1, you can see that this is an investigated barn surrounded by milking parlor, another dairy building. On the other side is the open field, and there are manure tanks, and etc. And you can see also in figure 1b, there's the dimension of the typical natural ventilated dairy building. And for the simulation, we have used ANSYS 2020 R1 workbench for creating a model geometry of 1:100 scale natural ventilated building with and without sounding, as well as for meshing and simulation. Simulation were performed for 4 wind direction. As you can see, this 0 degree, 90 degree, 180, and 270 degree. And the simulation results were validated by the previously measured data from a large boundary layer wind tunnel, as you can see in the figure 3, which is located in Leibniz Institute for Agriculture Engineering and Bioeconomy Potsdam. And we have used the same scale of the model as in the simulation as well as in the wind tunnel. And the mean stream air wise velocity profile within the boundary layer followed a power law, and we have calculated air exchange rate considering airflow rate and volume of the natural ventilated building. The result shows that the comparison between the experimental and numerical data of velocity profile confirm the validity of the numerical model used in the safety simulation. We have used K epsilon turbulent model for the simulation. And then with the further simulation, result shows that wind direction has significantly affected airflow distribution and intensity of airflow inside the dairy building, both with and without surrounding, through the inlet velocity, although the inlet velocity was the same. As you see in the figure 5, so there is a significant difference between the difference of airflow inside the building between the direction as well as with and without and with direction with the surroundings, and which is also you can see in the figure 6. The wind direction had large impact on the air exchange rate, which gave considerably higher air exchange rate value with 90 degree and 270 degree cases. The biggest difference in air exchange caused by the different wind direction was 52.2% and 65.1% for without surroundings and with surrounding cases respectively, as you can see in the figure 7. In conclusion, we can say that wind direction and surrounding affected airflow pattern, air velocity inside the investigated dairy building. Simulated difference in air exchange rate between wind direction can go up to 52.2% without surrounding and 65.1% with surrounding. And neglecting the surrounding can lead to overestimation of the air exchange rate up to 52% depending on the wind direction. Thank you very much for patient sharing.